so we're about to start with the last talk for the first session this morning. The presenter is Deyan Mihaylov from Cambridge. He's going to explain everything about the physics behind Interstellar.
Thank you very much. Hello, everybody. So, several months ago, a movie called Interstellar came out to the cinema. And I saw it, and then I saw it again, and I liked it very much. But all of my friends kept asking me, well, Dan, how does it all work? Wait, how in the end his daughter ends up older than him? Why is the space station cylindrical? What happens when you fall into a black hole? Well, since I can potentially answer some of these questions, I decided for this conference to prepare a talk exactly about this, about the physics behind Interstellar. Why do I feel qualified to talk about this? I'm doing a PhD in the Institute of Astronomy, and my topic is probing extreme gravity effects through gravitational waves. What this means is that, first of all, I look at black holes. So I look at different types of black holes. I look at charged black holes, spinning black holes, charged and spinning black holes, bodies which orbit them, bodies which fall into them, information which goes into them and then can't come out. And my current project is actually about gravitational waves. So what happens when you have a small body which orbits a black hole? This results in the prediction of gravitational waves. Now, this is only predicted theoretically, which is good because I'm a theoretical physicist. But if the two projects, LIGO and LISA, which aim at detecting gravitational waves, succeed, it will be probably the physics discovery of the century. Okay? Now, before I continue, may I just take a moment to wish everybody a happy Pi Day, because now is the third month, and it's the 14th day of the third month, and it's the 15th year, and about an hour and a half ago, the time was actually the first 10 digits of the number pi. And when you're a physicist, it's kind of a big deal. Now, I don't want you to believe me why the physics in Interstellar is true. What I want you to believe is that this guy says that the physics in Interstellar is true. Now, this is not Walter White switching from chemistry to physics. This is a chap called Kip Thorne. And until 2009, he was the Feynman Professor of Theoretical Physics at Caltech. Apart from that, he was actually he is still the leading academic in gravitational waves and cosmology. And in the early 90s, he actually won a bet against Stephen Hawking. I mean, if you win a bet against Stephen Hawking, you're probably onto something, okay? So what I'm going to do is I'm going to take you through the...
is it physics related?
Yes, it is physics related. It was whether a particular stellar object was a black hole or not. What Kip Thorne won from the bet was a year's subscription to Penthouse magazine. Now, what I'm going to do for the next 8.5 minutes is I'm going to take you through the movie and through the moments of the plot where physics played a major part. And I'm going to tell you what the physics behind it was. Okay? So, first of all, we can start with the title of the movie. Why is it Interstellar? So, in the not so distant, not so close future, humans have depleted their natural resources, although they can eat is corn, and naturally they're trying to switch planets to a better one. Now, this is actually a problem because apart from all the planets in our solar system, which are kind of uninhabitable, except ours, the closest solar system is the star Proxima Centauri, which is approximately 4 light years away. However, if you want to get somewhere which is 4 light years away, it means that you have to travel 4 years at the speed of light to get there. However, we want to go to somewhere which is habitable, so we want to go to a habitable extraterrestrial exoplanet. The closest such exoplanet is approximately 11.9 light years away. However, if you don't want to settle just for anyone, if you want to go to a good one, the best terrestrial exoplanet is 22 light years away. So we have to travel 22 years at the speed of light. I mean, even on the scale of this movie, this is a long time, okay? So what humans decided to do, they decided to find some other way. Now, the first way, which actually the producer of the movie, Christopher Nolan, wanted to depict was superluminal travel. Now, this is only reserved for Star Wars. And Kip Thorne explained very, very carefully that superluminal travel, i.e. traveling at faster than the speed of light, is not physically possible, and you need infinite energy to actually travel faster than the speed of light. So he managed to convince Christopher Nolan to employ another method of traveling such great distances, faster than light. Okay? So the next thing which you can consider is something called warp drive. So this is a spaceship which travels to space by contracting space in front of it and expanding space behind it. So even though in our flat universe, it does not appear to travel faster than light, it traverses certain regions of space faster than light. And mathematically, it actually combines the effects of traveling to a distant point and then traveling backwards in time. Now, there are many theories which say that this might not actually work. However, NASA are trying to build such a spacecraft and test it. So I'm going to leave it to them on theoretical physics, like I said. The thing that they chose to depict in the movie is actually a wormhole. So a wormhole is a tunnel. It's basically a tunnel between two points in the universe. But it's a tunnel which connects them in. So the best way to imagine a wormhole is a combination of these two pictures. So it's a tunnel which connects 2 points, but it connects them in such a way so that you can travel. If you fall into the tunnel, you get to the other side faster than if you would go all the way through the universe. Okay? So our characters from Interstellar had the fortune that they had one wormhole made for them next to Saturn, so they could use it. Unfortunately, we don't know how to make a wormhole, say next to the Earth, and use it to go somewhere. So this is not available to us. So if we want to travel to another solar system, we need to find some other way. But our characters used a wormhole, and it actually got them somewhere really interesting. They saw it took them next to a supermassive black hole. Now, let me explain what a supermassive black hole is, because it's something truly magnificent. There are several types of black holes. There is stellar mass black holes, which has a mass of several times the mass of the sun. There is intermediate, which is from between 10,000 to a million. And then supermassive black holes are actually between 1 million and several billion solar masses. So they're truly massive. So on this diagram, here in the center is the Earth's orbit, which is, so the Earth's orbit has a diameter of 17 light minutes. Now, this black hole, which is in the center of the NGC 1277 galaxy, has a diameter of 4 light days. When I was doing my undergraduate project on supermassive black holes, the largest one I was working with had a radius of 250 light days. So believe me, they are truly supermassive. Now, this is only an artist's depiction of a supermassive black hole. However, in the movie, we got to see something much more beautiful. We saw Gargantua, which is a supermassive black hole, but it looks much, much better. Well, I'll tell you that. Not only does it look better, but this is actually the real deal. So Kip Thorne worked very closely with the special effects company for Interstellar, and he gave them the equations which would seed the image of a black hole. Now, a supermassive black hole is this thing in the middle, and obviously, hopefully most of you know that nothing can escape a black hole, not even light, so that's why we can't see anything. However, since a supermassive black hole sits in the center of a galaxy, through a process called accretion, it sucks material from the galaxy and sucks it into the black hole. And this is why you see this luminal disk around the black hole. Now, this disk is in fact only in the plane, in the equatorial plane of the black hole. However, because of the massive gravity of this supermassive black hole, this disk is actually, you can see it, so the upper and the lower part you see are actually images of the behind of the disk, which you wouldn't normally be able to see if it wasn't so massive. So the gravity of the supermassive black hole bends those light rays, and they from behind the black hole, and you can still see them. And in this case, not only did Kip Thorne help Interstellar, but actually this image helped Kip Thorne realize why you see both images upwards and downwards of the black hole, and he's actually publishing a paper on that because of this image. That's pretty neat, keep to admit. Now, what they find next to this black hole is the first planet in their endeavors. So it's a planet which is covered in shallow water, but it is a very peculiar planet. Why? Because first of all, it has severe effect of time dilation. So 1 hour on this planet it amounts to 7 years on Earth. This is a factor of more than 60,000 for time dilation. Now, I'll tell you that actually the effect of time dilation is absolutely real, and next to a massive body, time passes much slower than far away from it. It is an effect which is used exclusively in GPS satellites at the moment. So actually, if the effect of time dilation wasn't incorporated in GPS satellites, you would never be able to see where you are on your phone. It would give you a completely wrong location. There is a similar effect in special relativity, time dilation in special relativity, and for it, time passes slower the faster you go. Okay? Now, this was only one of the peculiarities of this planet. The other one is that it actually, every hour or so, you witness massive skyscraper high waves of water. Now, this is caused because of the proximity of the planet to the black hole. There is, since the planet is so close, the gradient of the gravitational potential is so large that some parts of the planet are accelerated more than the other. This creates waves which sweep the surface of the planet and obviously cause the characters many troubles. However, there is a physical problem here, because if a planet is subject to such severe distortions of gravity, it would normally fall apart. It would be torn away by the gravity of the supermassive black hole. Now, Kip Thorne wanted to reconcile this with his actual physics theory. So what he did, he went back to the blackboard and he discovered that you can actually have a planet in this gravitational field if the black hole is spinning at nearly the speed of light. So he still managed to make physics work. Now, the last thing that is worth mentioning about this, if you go back to this photo, you see that it's actually a bright day. But it's next to a black hole, so it sort of doesn't make sense. The only source of light for this planet is the accretion disk. Now, the accretion, for those of you who do physics, know, but if the accretion disk is so luminous, then the only way it could be so bright is that it is also very active in the X-ray spectrum, which would almost immediately cause the death of the astronauts. Now, there is actually a paper by Kip Thorne and a guy called Novikov from 1973 on accretion disks for black holes, which proves that there is an intermediate process between an active and an inactive called quiescent black hole, where the accretion disk is still luminous enough to cast light on the planet, but it's not radioactive enough to kill the astronauts. Okay? So after that, our characters have their altercation on the second planet, and then after that, we only have 2 characters left, Amelia and Cooper. Now, they want to explore the third planet and hopefully find suitable conditions for life there. However, they don't have enough fuel. So what they do is they use a process which was actually used extensively in the Rosetta mission. The Rosetta mission last summer managed to land a spacecraft onto a comet. That's very, very impressive. Now, how they did it? They didn't launch it straight away from the Earth to the comet, but they used the gravitational pull of several celestial bodies to accelerate the spacecraft and finally guide it into the orbit of the comet. Now, things weren't so fortunate for Cooper, who decided to sacrifice himself and fall into the black hole. So, by falling into the black hole, you would normally die. So, the very same effect will apply to you. Some parts of you will be stretched, and some parts of you will be squished. Can anybody guess what this process is actually called? Spaghettification. Exactly, it's called spaghettification. And it's the process of being elongated more and more as you fall into a black hole. Now, this didn't happen to Cooper because the movie had to have a happy ending. So what happened instead to him is he fell into the 5th dimension, and obviously this is where the movie became less science and more fiction. And of course he managed to complete his mission. and then find his loved one. Thank you very much for your attention.
That was entertaining. I have to watch the movie. I suggest we should put like spoilers. Anyway, I'm sure there are many questions. Please.
I have a question.
Sure.
So you didn't answer why are they in a sphere in the end, and is it part of the fiction?
In a cylinder, you mean?
Yeah, well, whatever universe they end up being in. You said in the beginning that people start asking you always why do they end up in the universe.
The space station which they reside in the end, because the Earth is no longer habitable, has the form of a cylinder. So the reason why it has the form of a cylinder is that cylinders make very good space stations. On a space station, you're normally weightless because you're in the middle of space. In order to live comfortably, you want some gravity so that you can stand firmly on your feet. You can create gravity by spinning a cylinder, and the centrifugal force from the rotation of the cylinder would keep you glued to the inner surface. So that's why it's a cylinder, and that's why it's spinning.
As an astrophysicist, what's your favorite pet peeve in science fiction films?
I don't know. I've never given this any considerable thought. I guess I'm really interested in multiverse theory. I'm very fond of the idea that actually falling into a black hole might take you to another universe where the laws of physics might be different. So the gravity might not obey universe square law. Actually, it could be something else different. Yes? I've watched some of Doctor Who, yes.
I think we can find a lot of physics in there.
Yes, I agree. Question from you? Yes?
Should be the movie called Intergalactic because we're traveling to another galaxy.
Yes, but in the end they travel to another galaxy. You can write to the producers to tell them that they got it wrong from the start.
I think there will be copyright issues calling it Intergalactic.
Oh, I see. More questions? Okay, well, we are slightly over time.